All right, have you ever really thought about the sheer engineering magic that lets a massive airplane touch down smoothly? Today, we're going to dive into one of the most critical, but maybe one of the most overlooked parts of any aircraft, the landing gear. It's a total unsung hero, and you're about to find out exactly why. So let's kick things off with a bit of a riddle. What part of an airplane is absolutely essential when you're on the ground, but turns into a total liability the second you're up in the air? Yep, you probably guessed it. It's the landing gear.
Okay, so what exactly is its job when the plane's on the ground? I'll tell you, it's a whole lot more than just a set of wheels. It actually has a few non-negotiable, super critical jobs.
So there are really three main things it has to do. First off, it's got to support the entire weight of the aircraft. And we're talking about hundreds of tons here. Just think about that for a second. Second, it's what lets the plane move around on the ground, for taxiing and getting into position for takeoff. And third, and this is the big one, it has to absorb the absolutely immense force of landing. It's what turns a high-speed impact into a nice, smooth arrival.
But the second that plane gets airborne, the landing gear goes from hero to zero. It becomes a huge problem. See, it creates a ton of drag, which basically fights against the plane's movement and just wastes fuel. So what's the solution? Well, it's a pretty brilliant disappearing act. And that little problem right there leads us straight into the evolution of landing gear design. It's really a story of engineers trying to solve some core aviation problems using two very, very different approaches.
So what you're seeing here are the two main designs that have pretty much dominated aviation history. On the one side, you've got the classic, conventional gear. You'll often hear it called a tail dragger. And on the other, the modern tricycle gear. The difference in how the plane just sits on the ground is, well, it's pretty striking, right? And that posture has massive implications for both safety and performance.
You see, that old tail dragger design had some pretty serious drawbacks. Because its center of gravity was behind the main wheels, it was just naturally unstable on the ground. It was really prone to swerving or even tipping over in something pilots call a ground loop. Not good. Plus, look at that high nose. It totally blocked the pilot's view. The tricycle gear, though, it solves all of that. By putting the center of gravity ahead of the main wheels and keeping the whole plane level, it's way, way more stable. And bonus, the pilot can actually see the runway. So when it comes to performance, safety, and just being easier to handle, the tricycle design is the clear winner. It became the industry standard, and today you'll find it on pretty much everything, from little private planes all the way up to the biggest passenger jets. Okay, so we know why the tricycle gear won out. Now let's get our hands dirty and break down how this modern marvel is actually put together.
Now what you're looking at here is the landing gear from a Mirage 2000 fighter jet. Just look at that. You can see this incredibly complex dance of struts, hydraulic lines, and shock absorbers. It is one dense, powerful piece of machinery.
Now, I know it looks super complex, but we can actually understand how it works by breaking it down into a few key building blocks. Each little part has a very specific job to do, all about managing those insane forces of landing. First up, we've got the shock absorber. This thing is basically the heart and soul of a smooth landing. It's a lot like the suspension in your car, but on a much, much bigger scale. Its whole job is to soak up that massive energy on impact so the plane, and everyone inside, doesn't get a really jarring touchdown. All right, next we have the drag strut. This part is all about managing the powerful forward and backward forces you get during landing and especially during braking. It's basically a super strong steel bar that takes all that force and funnels it safely into the aircraft's main structure, like the wings or the body. And then there's the main brace. This component deals with all the side-to-side forces. This is especially crucial when you're landing in a crosswind. It provides that lateral stability, stops the gear from buckling sideways, and, just like the drag strut, transfers those forces safely into the airframe. So, we've established this system is incredibly strong and, yeah, pretty complex. But how in the world does it pull off that disappearing act? Let's take a look at the really elegant process of how the gear gets tucked away. The whole process is surprisingly simple, but totally ingenious. To lower the gear, a lot of the time, it just falls into place using gravity. It's a brilliant failsafe, right? A locking cylinder then snaps it into place so it's secure. Then, to retract it, that lock disengages, a joint breaks, and a really powerful hydraulic cylinder just pulls the whole system up into the gear compartment. Of course, not every plane lands on a nice paved runway.
So as you can imagine, the basic design of the landing gear gets adapted in some really fascinating ways depending on the job and the environment. I mean, a simple one-wheel setup on each strut is fine for a fighter jet. But what about a monster of a plane, like an A380? Its weight is so immense it will literally crush the runway. The solution? Pretty simple, really. Just add more wheels. And that's where we get these multi-wheel setups. A configuration with two wheels is often called a diabolo. Yeah, named after that juggling toy it kind of looks like. But for the true heavyweights of the sky, you get what's called a bogie. And that's a whole assembly with 4, 6, or sometimes even more wheels, all designed to spread out that incredible load. And the specializations don't even stop there. You've got skis for landing on snow and ice, you've got floats for seaplanes that need to land on water, and then you get some really unique designs, like the central wheels you see on gliders, or even the famous U-2 spy plane. So, when you trace its journey from those simple early tail draggers to today's complex retractable systems, you realize the landing gear is just a total masterclass in engineering. It's the perfect solution to that fundamental conflict between what a plane needs on the ground versus what it needs in the air. And it really makes you wonder, what's next? What will the next evolution of this unsung hero of the skies even look like?